In section 2 of chapter 3, we're going to move into physically graphing some linear equations and going over some of the techniques. Now, as we start off, we're first asked to identify, as we look at equations, whether they are linear equations in two variables. So linear in the sense of what makes something linear. Well, the key is when you look at either the x or the y component of the equation, is it to the first power? That is the exponent only a 1, or there's no exponent written there? So as we look at this is to the first, this is to the first. So is this linear? Yes. Now as you look at this one, we see here our x is to the second power. So that's not linear. Here we don't have an x, but we do have a y, and therefore it's linear. And this one, we don't have a y, but we have an x, and it's just to the first power. So this is linear. A little definition. As we continue to work on chapter 3, there are a couple of ways to develop data that you can graph, and one of the very common ways is to make a t-chart, which is what we see here. Now there's the equation, and they're giving us some points. So what we need to do is substitute in this equation the value for x, which will be 3 minus y equals 2. Well, I'm going to bring the y over to this side to make it positive, and the 2 over here to make it negative. So 3 minus 2 is a 1. So I've found that value. Now what I'm going to do is substitute the negative 2 for y. I'll do it up here. X minus a negative 2 makes it a plus 2 equals 2. So again, when we do this, we subtract 2 from both sides. We get x equals 0. And then we have another value for x here, which will be a negative 1. A negative y equals 2. Now again, I can bring the y over to make it positive, bring the 2 over to make it negative, so this is negative 3. Now the next stage is to take these ordered pairs and plot them on our graph. Now for you who are taking notes on this, you're just going to sketch a graph, and it'll be 3, 1, so over 3, 1, 2, 3, up 1, put a dot there, 0, negative 2, 0, negative 2, a dot right there, and negative 1, negative 3, so negative 1, negative 3. Now interestingly, you can see that we have some points that are in a straight line. So we take our graphing tool and just connect them. And this is the graph of this particular equation. Now for this one, we're going to do the same thing. If x is 6, we can go y equals negative 1/3 of 6 minus 2. So a negative 1/3 of 6, this cancels out nicely, and we get a negative 2, and a negative 2 will give us a negative 4. Now if y is 3, we just do it this way, 3, negative 3, and a negative 1/3 x minus 2. Well, here's a case where we would like to get rid of the fractions. So we're going to multiply everything by 3. Here the 3's cancel out. We get a negative 9 equals a negative x. And this is going to be a negative 6. Now we want our x to be positive, so we'll bring the x over to this side. Bring our 9 over to this side as a negative 9 on this side is a positive 9. So this gives us a 3. Now if y is 0, we'll put a 0 there. Negative 1/3 x. I'll bring the negative 2 over there. This will become a positive 2 then. And we'll take it, multiply this by its reciprocal, a negative 3 over 1. And a positive x then equals a negative 6. So let's plot these points. 6, negative 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 3, negative 3. 1, 2, 3. Negative 3 right there. And then negative 6, 0. Negative 6. 1, 2, 3, 4, 5, 6. And there we get a nice line here. Okay, now are there any other points on these lines? And the answer is yes. There's an infinite number of points along these lines. And how did we get these points? Well, we had a t-chart where we had some values. We found the other value by substituting in the equation, and these points line up along a straight line. These are linear equations. Now, every once in a while you'll be working on a t-chart and you may get a point that's up here, let's say. Well, that's an error. Since these are linear equations, the points must be in a straight line. If you get one that's off the straight line, then you know you've made an error somewhere. Now in MATLAB, all you need is 2 points to make a line. Here we use 3 points to give us a little more accuracy when we draw our diagrams. Now on some of these, they may be a little easier than others to do, but let's give you a chance to work on letter C. So the first one, if we substitute a negative 6 there, this becomes a negative 2, and then 2 times negative 2 gives us a negative 4. If y is 0, then if we use the reciprocal of 0, it's still 0, so that's 0. Now y is 10/3, And we end up with this. We're going to multiply both sides by 3. That cancels out. And we get 2x equals 10. Divide both sides by 2. We have x equals 5. So graphing these, -6, -4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 0, 0. And then 5. 1, 2, 3, 4, 5. Now 10 is like 1, 2, 3 and a third. Right there. And we get our line tool. And there's this graph. Now this one's a little tricky. Because here we're saying y is equal to 3. So all we do here is put in y equals -3. So now we graph those 3 points. X is a 2 and a -3. So x is 2, -3 is right there. X is a -1, and y is 3, a point right there. X is 0 and a -3 right there. Now this is a case, and we're going to be introducing this. A special form of the equation is y equals b, and this is an equation of a horizontal line that goes through the y-axis at this point B, which is what is called the y-intercept. We'll be studying that a little later. So a special case, if you just have the one letter y equals something, then that's a point somewhere on the y-axis where the line horizontally goes through it. And you can click there and one other place to make this line in MATLAB. Now in letter E, F, and G, they don't give you a pre-made t-chart. So here we make our own. X and Y. And we can put a value for x as 0, -1, and a +1. The same thing here. Let's put x and y. A -1, a 0, and a 1. Now here are values of x. We have to solve for x. We're going to get x equals 2. So our value for x will always be 2. So what do we do for y? Well, we can put any value here. -1, 0, 1. Okay, so let's take some time solving the equation for these values, and then we'll graph them. Okay, got these values, plotted them, and that's what the graph looks like. Remember, there's an infinite number of points. Now, why did I choose these values, you might ask? Well, they keep it near the origin. I don't want to choose like 100, which is not on the scale at all. And notice these lines are similar, but not quite the same. Now here's a case where instead of a horizontal line that we got when we did y equals b, when we have x equals a, in this case x equals 2, we get a vertical line. So these are some of the special formulas we'll be working with as we continue on the chapter. For the last example, they give us this equation, which deals with the value of a house increases in value for this many years after the purchase. And this is the equation that explains it or defines it. So what I did is I made this line here 100,000. This line here 200,000. And I put 120,000 about there. And then after 5 years, it's going to go up, that I've worked out already. So this is what the line indicates. Now, what's the trend of this? Well, it's going to go upward. It's increasing. So we made a graph, and this would be very hard for you to do. The numbers are way too big. I'm surprised they gave us this one. But now they want us to complete this ordered pair. Well, we have y equals, our x value is 5, so we go 7,500 times 5 plus 120, and we do this multiplication, and when we add it all together, we get y equals 157,500 here. Now, what is the meaning of this ordered pair that we see here? This is going to be 5, and y would be 157,500. Didn't leave us that much room. So what's the meaning of this? Well, after an original purchase here, in 5 years, the house would have increased in value, so now the house would be worth this much money. And theoretically, according to this formula, it's going to increase in value this much each year. This is the number of years, and this may be the value of the house or what you paid for it initially. And there's the graph. All right, we'll be doing a lot more work with graphing and finding more about it as we continue other topics.